My name's Sean Moules. I work for the Nuclear Decommissioning Authority for RWMD, the Radioactive Waste Management Directorate, and that's the part of the NDA that's responsible for delivering the geological disposal facility. I did originate my life as an engineer, and I spent the last 20 or so years in various project and program management related roles. I was debating whether to say a project and program management professional. I've got lots of letters and certificates, but I think the professional bit takes a bit of delivery and a bit of track record, because sometimes marrying the theory to the practice is quite challenging, especially the human aspects. And there's a lot of that within this program. Just a little bit about the NDA. I know a lot of you are familiar with it, and I apologise for that, but I know some of you aren't, so I'd like to spend a couple of minutes just laying the ground and foundations for that. It's a non-departmental public body, or a dreaded quango if you're a Daily Mail reader. So we're independent from, but accountable to the government. We're 5.5 years old as an organisation. Not that old, but largely we're a strategic body. We set the strategy, we bid and place and administer the contracts with the sites, and then the site licence companies do the physical work for us. Our remit is the civil public sector nuclear liability, and as it says there, most of our sites were built around the 1940s and later, and so there is a legacy that's built up there. There are 19 sites that we took over from what was BNFL and UKEA. Our annual funding is just under £3 billion. That comes about 50-50 at the moment from commercial revenue from the 2 remaining generating sites, and from reprocessing contracts at Sellafield, and from asset sales like the land that we sold to support the new build programme. The remainder of it comes in grant in aid from government. Our sponsoring body is DEC, the Department of Energy and Climate Change. And where the money gets spent around those sites, currently around £1.5 billion of it each year gets spent at Sellafield. And our head office is based in Cumbria, near to the Sellafield site. So, our mission, everybody has a mission. Ours is to deliver safe, sustainable and publicly acceptable solutions to the challenge of nuclear cleanup and waste management, and the 4 legs that support that: never compromising on safety and security, taking full account of our social and environmental responsibilities, seeking value for money, and engaging with our stakeholders. I'd like to dwell on those just for a moment, because they are perhaps a little different than you'll find in some private sector companies. Obviously safety and security is always number 1 on the nuclear agenda, but taking full account of our social and environmental responsibilities really reflects that our remit doesn't just end at the factory gates, if you like, at each of the sites. We have to take into account in our work that as the decommissioning programme is completed and eventually ramps down, that has a big impact on the local communities. And it's our job to help mitigate those impacts, and so that we have that built into our mode of operation, if you like. Always seeking value for money. Obviously that's very critical in the current fiscal environment, and the pressure on that is constant, and certainly isn't going to decrease in the foreseeable future. Actively engaging with stakeholders, as it says there, publicly acceptable solutions. It's very important to us that for us to maintain and deliver our mission, we do it in a way that is acceptable to the many stakeholders that we deal with. So, geological disposal of radioactive waste. The UK has been a nuclear nation for a long time now, so that does give a legacy of long-lived wastes that have to be managed in the long term. A lot of that material is already there and has to be dealt with irrespective of what happens with the new build programme. There are also other materials, spent fuel, plutonium and uranium, which at the moment are classed as zero value assets, but depending on what happens in the future, including with the new build programme, they may be classified as waste in the future. And even if they do get reprocessed or reused as fuel in the reactors, ultimately there will be waste left at the end of that, which will still need to be dealt with. And the new build generations themselves, albeit they're built with efficiency of design, operation and decommissioning in mind, and they are a lot more efficient than the first generation of reactors we're dealing with now, they will generate obviously further waste. And the last point on there, which is probably the most important, is that the waste will be hazardous for circa 100,000 years. The life of the interim stores that we're building and have built so far is around about 150 years. And if you do a simple sum to divide one by the other, you realise that if you stay with surface storage, that you'll be rebuilding those stores an awful lot of times. Basically every 5th generation or so, we'd be saying you have to take the material out of those stores, rebuild another store and move it to that. That's a lot of handling and a lot of burden on a future generation. The other thing I'd like to sort of cover there is that, can you predict what's going to happen over those timescales? Do we have any idea what society will be like in a few thousand years, or 10,000 years, or tens of thousands of years? It's about 5,000 years since the first civilization in Egypt in a recognisable form came about, and we're talking about anything up to 100,000 years. You cannot predict over those timescales what's going to happen to society, the monetary system, or anything else. We couldn't predict a year in advance a global financial crisis. So can you really predict ahead on those timescales? You know, that is, to quote a Rumsfeldism, a known unknown. One thing we do know is that geology is something that is pretty stable, and depending on where we site this and where we do the geological investigation, we can say that a body of rock has remained unchanged for several million years, and we can reasonably predict in the right areas what will happen to that for the timescales that we're looking at. And that, in essence, is why geological disposal is the solution that's being taken forward. If we kept with surface stores, you know, these timescales are beyond the next ice age, for example. And, you know, if it was me and I was there in 10,000 years and there's a glacier half a mile thick rolling down towards the store, my number one priority might not be, oh, I should empty that store and move the things. I might more be interested in what will I have to eat, where will I live, will I be able to survive? So, a little bit of history, more recent history. The planning application for a rock characterisation facility was submitted by NIREX and refused in 1997. A rock characterisation facility is basically an underground lab that would be at the sort of depth that we would host the geological disposal facility and carry out the experiments into that. There was then a review in '99, and that basically said that decide, announce, defend was not the right approach, and that stakeholder engagement was key to moving forward. There was a UK Citizens Conference, and that showed that the public could and would engage with long-term radioactive waste management. They wanted to get involved with it. So the government launched a new programme in 2001, and the four legs of that were to achieve long-term protection of people and the environment, to do it in an open and transparent way that inspired public confidence, to be based on sound science, and to ensure the effective use of money. So what happened then? They launched the Managing Radioactive Waste Safely programme, or MRWS. Started with a period of consultation and consideration of responses. They established a body called Quorum, the Committee on Radioactive Waste Management, and that was an independent body with a number of experts from different fields, and they led the research and the public debate. And it's worth pointing out that they did a lot of blue skies thinking with that. They looked at really all of the different ways that you could theoretically dispose of waste, from firing it into space to putting it at the North Pole and letting it melt its way through the ice sheet down to the bedrock below, to putting it between tectonic plates and let it be gradually subsumed into the Earth's core. They really did do some blue skies work. They then narrowed that down into a deliverable set of solutions based on public acceptability, affordability, technical feasibility, and so on. And they made their recommendations to government of what they thought was the best way forward. The government accepted those recommendations, and then the government consulted on implementing the recommendations. And then really from 2008 onwards, the white paper was published in June 2008. In parallel, they invited local authorities to express an interest in finding out about what hosting a geological disposal facility would mean. They gave out information packs, and they also started consultations on the siting process. So the purpose of the white paper, the government's set out the framework for the government's managing radioactive higher waste system. It indicated how such a process would be designed to deliver something that was safe and secure, and also address the issues of interim storage of the material that's there now and will be packaged in the coming years, and the research and development that would be necessary to ultimately deliver the programme. They also wanted to invite communities to open without commitment discussions about what it would mean to host the facility. So the areas that the white paper covered were broadly the amount of waste, what was going to go in it, the NDA's preparation and planning, what were we going to do to deliver this, how regulation planning and independent scrutiny would work, site selection and volunteerism and how partnership would work, and the site assessment process itself. So the waste to be managed are broadly higher activity waste, so the high level waste, intermediate level waste, and waste that's low level but not suitable for disposal of the low level waste repository near Drigg in Cumbria. Also, there could be spent fuel, plutonium and uranium, depending on decisions that are taken with that going forward. And they published a 2007 inventory which gave more information on that, and that will be updated periodically to keep it current because it is something of a moving feast. So, in terms of what goes in it, the headline figure at the bottom there, around 500,000 cubic metres of material. By volume, the vast majority of that, around 80%, is in the intermediate and low-level waste and uranium if that goes into the repository. Only a small amount by volume is the high-level waste, really just a few percent if you include both high-level waste and spent fuel. By activity, obviously, almost the reverse of that is true. The vast majority of the material, circa 90%, is in the high-level waste and spent fuel in terms of activity levels, and just a few percent in the intermediate and low-level waste. So, what are we doing about it? The NDA Radioactive Waste Management Directorate was set up, and that's responsible for delivering geological disposal. And we're at the moment, as of December 2009, a prospective site licence company, and the view is that we'll eventually be spun off to create a site licence company to deliver that work, recognising that the site ultimately will be a nuclear licence site once it takes nuclear material. And we're taking decisions now that will affect a nuclear licence site and hence the regulatory interest. We've published Geological Disposal Steps Towards Implementation, which lays out our approach to delivering this. The planning is being progressively developed. We already have a baseline that covers the life of the programme. It's kind of ironic that this is both last in the process in terms of the presentations and also where it sits in the waste cycle, and also it is probably the longest programme that's around. This is over a 100-year programme of both the site investigation, physical construction, a long period of parallel construction and emplacement, and then final closure of the repository. It's over 100 years. The lifetime value of the entire programme is around £12 billion, and that to first waste emplacement in 20 to 30 years, that's circa £4 billion. So, you know, in context, the size of the programme is substantial, you know, bigger than the Olympics, albeit on longer timescales. We are drawing a lot on overseas experience. We have bilateral agreements with most of the other waste management organisations around the world. We're sharing some of the research and development that's going on and participating in that and drawing that into our own programme. But even so, it'll be 2 to 3 decades until the first package is placed in the repository. A little bit difficult to read that, so I'll just run through it very briefly, but we've already passed stage 1 and 2, which was the communities being asked to express an interest. Stage 2 was a consistently applied subsurface unsuitability test. That doesn't exactly roll off the tongue, but to explain it a little bit more, we commissioned the British Geological Survey to carry out research in the areas that had come forward and volunteered to express an interest, to screen out areas that you wouldn't by default want to build a repository in. So we're talking about screening out things like aquifers and water supplies, coal deposits, mineral deposits, the kind of things that a future generation might want to mine down or drill down into at a future date, and obviously we wouldn't want them to do that anywhere near a repository. So the BGS report has screened out the areas that you wouldn't want to take forward in the normal course of events for a repository, and that leaves then a very large area that is still suitable for hosting a repository. Stage 3, the box over here, is community decision leading to decision to participate. So 2 communities have expressed an interest. That's Copeland and Allerdale. They're both in Cumbria. Copeland is where the Sellafield site sits within. Allerdale is just to the north and has towns like Workington in it, where a lot of the people who work at Sellafield work at. So they're both communities that are well engaged in the nuclear programme and understand a lot about what it means to host nuclear facilities. They've got a programme of work that basically for them to explore what it means, what the local people think, engaging with their stakeholders, which will lead them to a decision to participate in circa 12 months' time, we hope. Stage 4 is then desk-based studies, which is basically moving from areas to sites and looking at the geology of particular sites, Stage 5 is surface investigations, which is the commencement of borehole drilling and the below ground physical investigations. Depending on the complexity of the geology, that's circa 10 years to do a full evaluation of a site, looking at everything, looking at the strength and composition of the rocks, how fractures work within it, how water movement works, the geology and chemistry of the rocks, the whole water flow in the surrounding area. It's a very complicated and multifaceted piece of work. And stage 6 there is underground operations, so the physical mining and construction of the repository. So the design concept is to immobilise the waste in packages. Obviously a lot of that is already underway and there is already a sizable amount of waste in storage. Interim stores have been built and are being built to house that material. It'll then be transported to the facility, and then the facility itself uses both man-made and natural barriers to prevent and minimise the escape of radionuclides over time. So the surface facilities are relatively small. The below ground footprint, this isn't a cavern by the way, it's just an exploded diagram so that you can see the tunnels underneath, would take up several square kilometres, obviously depending on the volume of material that goes into it. But there are basically two types of facilities down there. The first is vaults or caverns, which are for the intermediate level waste. And then there are a series of deposition tunnels, which would be for the higher level heat generating wastes. Obviously due to their activity and the heat generating nature, they would be a lot more spread out. In terms of access to the facility, there would be a drift or an inclined shaft that's the main access point for taking material down into it, and then in this illustration 3 shafts which would provide ventilation and other services. And in terms of the location, there's some flexibility in where exactly the below ground facilities sit. There can actually be some distance from the surface facilities.
In the UK, after many years of listening to a wide range of views, the government decided that geological disposal is the best way forward. The design of a facility will depend on the rock type at the finally agreed location. The following animation gives an indication of how such a facility could operate. Despite little visual disturbance to the surface, safely below lies a geological disposal facility. Here, deep underground, engineered vaults allow the waste to be kept until it is decided the facility can be sealed. The underground facility will have 2 main areas, one with tunnels which will contain heat-generating high-level waste, while the second network of vaults will house intermediate-level waste. Intermediate-level waste arrives in 2 forms, unshielded and shielded. Let us follow an unshielded package's journey through the geological disposal facility. The waste will be transported to the facility in specially designed secure containers by rail, road, or sea. This transport container is designed to withstand severe impact and protect workers and the general public from harmful radiation. All transports are regulated to stringent international standards by the Department for Transport to ensure controlled and safe passage. Once inside the facility, the transport containers are transferred by crane onto a drift wagon. Which descends on a steep incline deep underground to approximately 650 metres, where it arrives at a specialised reception area. The wagon covers are drawn back and a heavy-duty crane lifts and moves the transport container to the inlet cell. With the roller shutter closed behind and the outer shield door open, the container is moved into the lid unbolting station. The container is monitored remotely with the aid of robotic manipulators and scanning devices. Upon completion, the container moves to the lid removal station and onwards to the package removal station. Once in position, an anti-contamination shield descends and the package is lifted into the container transfer area above. From here, the the waste package travels to a position directly below the emplacement fault. A shielded viewing window makes direct inspection possible at this point. Once remotely secured, the waste package can be moved and stacked in a predetermined position. Utilising the same initial stages of the process as just seen, shielded intermediate level waste finally arrives underground at a dedicated buffer area. A heavy-duty forklift truck picks up the package and transfers it to the emplacement vault. For safety and security reasons, high-level waste and spent nuclear fuel would be handled differently. Arriving in the tunnel, the automated vehicle is positioned remotely over the deposition hole. The machine splits and rotates to a vertical position over the hole. An onboard winch system engages with the disposal canister and lowers it into the hole pre-lined with special clay called bentonite. To cap the deposition hole, the bentonite plugs are winched down into the top rings. Once the deposition vehicle is moved off, both the tunnel and remaining hole are backfilled with a mix of crushed rock and bentonite.
A lot of those ideas have been tested at scale size in some of the other European programmes. So whilst we haven't done the trials here in the UK, we are working closely with organisations like SKB and Perceiver, who are well progressed, and obviously in a number of other countries they're also making good solid progress on geological disposal. So in the UK then, we're continuing with the siting process based on volunteerism and partnership. As I say, 2 borough councils have formally come forward to express an interest, and Cumbria Council, on behalf of them, has said it will support any of its local councils that want to get involved. So those two, between them, cover a fair area of Cumbria. So the West Cumbria has established the Managing Radioactive Waste Safely Partnership Group, and the British Geological Survey has moved on slightly from this slide. It has undertaken and completed its survey. So they've established the MRWS partnership, and it's an advisory body, and its mission is to make recommendations to Allerdale and Copeland Borough Councils and Cumbria County Council on whether they should formally take a decision to participate. And that, even at that stage, is not an irrevocable decision. They still have a right to withdraw as the programme progresses. In terms of our public and stakeholder engagement and communications work, obviously there's a lot of meetings and leaflets going on, and they have their own website, West Cumbria MRWS, which has a lot of information on that engagement work. At the moment we're heavily involved in making a generic disposal system safety case, and that covers transport, operations and all the short and long-term environmental and other aspects. That's backed up by a number of underpinning status reports, and those, if you like, are basically a state of the nation of where we are with research on all the different factors that underpin that: biosphere, geosphere, release of radionuclides, gas migration, all those other areas. There's a lot of science that sits behind it, and what we've done by producing those reports is identified where there is further work that we would need to do to ultimately make the final safety case. We're continuing to work with partnership with host communities. This is a long-term programme, we're in it for the long haul, and we're confident that it's the right thing to do. Thank you very much.